Everyone, and welcome. I'm Adele Lewis, Community Manager at Reliably and organiser of the Shift Left Reliability Meetup. So just to kick off with some housekeeping, whilst the talks are on tonight, if you can keep yourself on mute during this time, after there will be plenty of time for Q&A and also a chance for an open discussion. So you'll have a chance to join us on screen and come off of mute then. We're going to be recording the session, so this will be made available at the end, and we will post it out on the Meetup page if you'd like to rewatch anything from today. Just an update, our second speaker for tonight is unfortunately unable to join us due to a family emergency. Arnold sends his apologies and hopefully he'll be joining us again in the not too distant future. So tonight, that means that we've got one talk for you, and we're very delighted to be joined by Charity Majors, co-founder and CTO of Honeycomb. So Charity, welcome. If everyone can now go on mute, and if you want to share your screen or begin, over to you.
I'm going to be talking about it is time to fulfill the promise of continuous delivery, aka 15 minutes or bust. And some of you might be wondering, why are we going on and on about something that was, invented 15 years ago and that we're all presumably doing by now? Like, what is left to do? That's a great question. I'm so glad you asked. I will skip right past this, except to note that the observability engineering book there in the middle is currently at the printer. You can actually download a digital copy for free. If you look at the Honeycomb.io Twitter account, we've been posting a URL where you don't even have to give your email address. You can just download the copy for free. You'll be able to. You can already pre-order the book online at Amazon and everything. And that is a maned wolf, in case you were curious. Liz Fung-Jones and I, and George Miranda and I have been working on this book for 3.5 goddamn years. I just found an email the other day from when we first sent out we were signing papers with the O'Reilly folks, and this was in like June of 2019. And I was like, well, I think we'll be half done by December. And I think we'll have the full manuscript to you by February. So long story short, it did not happen. And 3 years later, here we are. But I think it's a good book. I think there's a lot of useful stuff in it. If you're interested, go download it. Okay, on to the talk. How many of you have ever said something like this or heard something like this said? I will do whatever it takes. That's the job. I will fall in that grenade. And here's where I'd be like, if we were in the same room, I'd be like, okay, all of you who come from ops, like, be honest, raise your hands. Even if we don't say it out loud because we're cynical fuckers, like this is like the attitude that a lot of us have, which is just that we take a lot of pride in our work. We take a lot of pride in doing things well. And often, especially in our 20s, this means sacrificing our own well-being. Or if you move on to management, sometimes it sounds like this. Sometimes you just have to sacrifice your team in order to make your users happy. Sometimes you just have to. And while I don't think anyone would debate the fact that in the short term, there are sometimes grenades that need to be jumped on, over the medium to long term, this is bullshit. Like, it's a big lie. I've never seen a happy team with miserable users long-term, or vice versa. They tend to rise and fall together. Great engineers who are, engineers who are doing great things, who are creative and engaged, tend to make better products, tend to, have better user satisfaction. It's more fun to be a good engineer than a crappy one. It's more fun to do a good job for your users. It's more fun to delight them. And it's more fun to do your work when you're awake and engaged and you feel like doing it and you're doing interesting stuff, right? I don't think anybody's going to argue with this. In fact, you're all probably going, duh. No doubt, absolutely duh. And what all this boils down to is you want to be on a high-performing team. We all do. Be a higher performing team. And I know, easier said than done, right? But a lot of us don't stop to think of it in these terms. We get so down in the muck and the day by day and the shipping the features and everything that we don't really take a step back and look at the overall health of the team and how to get there. It's easier said than done. And a lot of times when teams are underwater, the first tool that they reach for is hiring. And you cannot hire your way out of this problem. If you have a team that isn't performing terribly well and you add a bunch of people to it, it doesn't make your team better. It usually makes your team worse because you've just added more areas, more points of contention, and more people who are trying to schedule for the same amount of work, the same amount of stuff. A lot of this has to do with tools and telemetry. A lot of it has to do with keeping up on what's new in tech, which is not to say that the newest is always, shiny and bright and awesome. But I mean, keep in mind that if you're a technical team, your steady state is losing ground, right? If you're just plugging away week after week, you are slowly but steadily losing ground. You're becoming less and less effective over time because you're constantly accumulating, surface area, you're accumulating bugs, you're accumulating responsibilities, you're accumulating things that you have to be on call for. There's, just entropy, things are constantly getting worse. Like, you're not imagining it. Things are constantly getting slightly worse. And the way to get ahead of this is to look for, not just, best case, if you're hiring, best case is you're adding your capacity to deliver linearly, right? Best case, you're adding capacity linearly, but you need to be looking for step functions, opportunities to make your team 10, 20, 30% more efficient on a regular basis, just to keep up and stay ahead. So, how well does your team perform? Loaded question. But note that this is not the same thing as asking, how good are you at engineering, right? These are very different questions and they have very different answers. High-performing teams are the ones that get to spend most of their problem doing interesting things that move the business materially forward. Lower-performing teams, and by this, I'm not talking about bad teams, but I'm talking most of us, 75% of all teams, right? Spend their time doing other stuff, everything else, right? They spend their time doing everything else. They spend their time doing all the stuff that they have to do in order to get to the stuff that they want to do. So how high performing is your team? Hello, Echo back. I'm not the dog. Somebody needs to mute. Thanks. I think the best way to answer this that I've found is, the DORA metrics. Everybody knows these. How often do you deploy? How long does it take? How often does it fail? How long does it take to recover? I would add a fifth that everyone should definitely be paying attention to, which is how often does your team get alerted outside of work hours? Because this correlates so closely to teams literal burnout. And it's not the same thing as, how healthy is your system, because the two can diverge by quite a lot. But there is a huge gap between the quote unquote elite teams and, like I said, the rest of us, the other 75%. This is the difference between deploying in under an hour and under a day, right? This is the difference. Well, this is the difference between restoring service in less than 1 hour or more than 6 months, right? And if you look at this year over year, what you see is more and more teams are muscling their way into the elite. But most of us, are actually losing ground. And it really pays off to be on a high-performing team. Think of the sheer amount of human misery that is contained in this gulf and the competitive advantage for teams who get to improve and iterate in the way they build together, many times a day. So how do we build these high performing teams? Well, you want to hire the smartest people you can. You want to, hire everyone you can from MIT and Stanford, aggressively poach as much talent as you can. Sorry, wait, that was wrong. That's the way most recruiting organizations seem to approach hiring, which is really backwards, because great engineers don't make great teams. If you hire the best engineer in the world to come and join you, but it takes you 3 days to ship a change, it's still going to take them 3 days to ship a change, right? It's actually the other way around, which is that great teams are what make great engineers. The thing that makes a Google engineer great is typically not their skills going in, but the fact that they got to work on one of the world's largest, most complicated and interesting systems for a few years. That's what makes them great, right? And great teams, like, just think of the amount of when you're on a good team, you're learning same defaults, you're learning good best practices, you're learning like skills that it's taken thousands, hundreds of thousands, millions of engineering hours to evolve to and arrive at, and you get to just sidle up to the bar and get it served to you like, oh, this just makes sense, right? The team is what delivers. The smallest possible unit of software ownership is not the individual, it's the team, right? If only one person knows how to own each service at your company, you've got a lot of bus problems. And which of these two kids is going to be the better engineer in 2 years? The one on the left who joined the quote unquote elite team and is deploying many times a day, or the one on the right? If they were perfectly equal going into this 2-year period, the kid on the left is going to be in way better shape at the end. She's going to learn so much more. Because, what happens when, an engineer joins a team? Well, within a few months, their productivity tends to rise or fall to match that of the team that you join. And this is because, yes, your knowledge of algorithms and data structures absolutely does matter. But your ability to ship code swiftly and safely has a lot less to do with your personal knowledge and a lot more to do with the socio-technical system that you participate in. How quickly you can move, how often you can deploy, right? There's actually a term in sociology to describe this, the FAE, the fundamental attribution error, which is that we tend to attribute most of a result to our own individual capacity and very little of it to the system around us. It's like 80% all me and 20% the system. When in fact, it's like the reverse. It's like 20% you and good for you. You should do that. But it's like 80 or 90% the system around you. And if you agree that like the smallest unit of software delivery is a team, then, I think there's no question but that technical leadership, whether you're an IC, whether you're an individual contributor, whether you're a senior engineer or a manager or a director or whatever, like you should pay a lot of attention to all of the feedback loops that are at the heart of the socio-technical system. Feedback loops like code review, feedback loops like, oh, hey, this brings us to CI/CD, which is probably the single largest, most all-encompassing, most powerful feedback loop of all. And remember, these socio-technical systems, they're not quote-unquote complicated systems. They're complex systems because their outputs feed back into themselves, right? So, making a change upstream tends to have a lot of ripple effects, and it tends to percolate all the way down, and instead of like improving something linearly, you can actually like make like exponential improvements if you find the right lever. I would argue that fear around deploys is the single largest source of technical debt in almost every organization. Fear around deploys, or nervousness, or just the sheer amount of time that gets, spent delivering software and dealing with releases. But, everyone does CI/CD these days, right? Sure. I love this quote from our Intercom friends, which is that shipping is the heartbeat of your company. Shipping new code should be as small, as ordinary, as regular, as nothing burger, as a heartbeat. It's like the 808 drum, underpinning your entire organization. It's regular. It's not something you have to think about. It happens automatically. If you do nothing, deploy goes out. You have to do something in order to stop your heart from beating. And CI/CD is how we get there, right? So if I ask you, do you do CI/CD? You're going to be like, probably like, yes, absolutely, we do CI/CD. But if you start probing more deeply, it often comes down to, Well, we run CI. That doesn't count. CI is only the appetizer. It's what opens the door. The entire fucking point of CI is to clear the path for you to do CD. And by CD, I don't mean continuous delivery. I think that's a weasel word that I understand why, 10, 15 years ago, that's the best we could do. We could get things to a state where they could deploy at any point, but they didn't deploy because they didn't have the tooling. They didn't have observability. They didn't have, a lot of things that we have these days. Continuous deployment is what will change your life, literally. Continuous deployment holds the feedback loop that has the power to transform your team and its ability to ship software. What this looks like is, once you merge your code domain, it should automatically be deployed by default with no manual gates in 15 minutes or less. If you aren't going to hook up CI to your production systems, honestly, just run it on your laptop. Why even bother with CI? Because it's exactly the same amount of value for far less hassle. I would go so far as to say that any CI/CD job that ends without having deployed your code to production was a failed run. This is the beating heart of your company. This is the core feedback loop of software delivery. The speed, coverage, and cadence of your CI/CD pipeline will basically set the bar for how high-performing your team can be, more than any other variable. And the job of engineering leadership is to tune this system, this feedback loop. So if you're like, okay, got it. High-performing team, check. Good feedback loop, cool. What does that look like? Well, I'm glad you asked. It looks like this. Engineer merges a change with any user visible changes hidden safely behind a feature flag, which triggers CI to run tests and build an artifact, which is then automatically deployed or canaried to an environment with real users. Doesn't have to be production. At Honeycomb, we have the production system. It's instrumented, and its instrumentation goes to the dog food cluster, which is instrumented, and its instrumentation goes to the kibble cluster. So we automatically deploy to dog food. And then, we have a bunch of automatic health checks. It sits there and it bakes for about an hour, and then it automatically gets promoted to production, like an hour or some point, maybe 15 minutes later, right? So if it didn't deploy successfully, obviously that gets halted, rolls back, alerts someone. But the point is, it goes out to a place that's real, that has real users, right? Even if they're internal users. And very important, 15 minutes or less. You'll notice that in this feedback loop, there's only one change set per engineer per build, right? You're building an artifact with only your changes, nobody else's. There's no manual QA. It's almost as important that this be predictable as it is that this be a small amount of time. I would actually say I would rather have a predictable 20 minutes than a highly variable 10 to 30 minutes. And you're using feature flags, very important, to decouple your deploys from your releases. I need to make a slide for that. Sorry, making a note. And as the Mandalorian would say, this is the way. This is the way. This is the way to build software. This is a way to build great teams. And why? Why is it so important? It's all about that precious interval of time between when you're writing the code and when the code is out there. Keeping that interval small is everything, because at the moment when you have finished solving the problem, you have everything that you need to debug that problem in your mind. You know what you did to solve the problem. You know the things that you tried to do that didn't work. You know what the variables and functions are named. You know your original intent. This original intent can never be recaptured by anyone else. You know as much about the software as anyone will ever know about it, right? And how long does this last? Not long, right? It lasts until you move on to another problem and you page it out, right? This is why in that precious interval, if you practice observability driven development, by which I mean you instrument your code as you go, you automatically deploy it, and then you go look at it and you have observability. And then you ask yourself, through the lens of the instrumentation that you just wrote, you ask, is it doing what I want to do? And does anything else look weird, right? If you just look at it, engineers will find like the majority of all bugs, and they'll fix them so much faster. I need to add a slide about this too, because the cost of finding and fixing bugs goes up exponentially from the moment that you write them. Having a predictable interval is what lets you hook into the body's own reward system. So, when you merge your code, your body will sit there and it won't feel like you're done until you've looked at it in production. A short interval also lets you hold the line against batch deploys. Now, if you know your change is going out and you can look at it in 15 minutes, you're very likely to go and look at it, especially if it prompts you, right? And if it serves up a URL. At Honeycomb, one of the things we do is when you're merging your code, it'll ask you, how are you going to know if this works or not? And what are you going to look for when you're trying to validate it? Which is fantastic, right? So there's a prompt you have to write, you have to answer those questions to merge your code, and then you go look at it. If, on the other hand, you're merging your code and you're pretty sure that at some point in the next hour to week, your changes are going to go out along with 0 to 50 other people's changes, you're never going to look at it. You're never going to, right? So like this right here is the feedback loop within a feedback loop that gives you software ownership. If you're deploying people's changes in a short amount of time, you can hold them accountable for checking on them and just looking at them and making sure that they're working correctly. If you're not, you kind of can't. you're kind of going to be relying on your SREs and your ops teams and like whoever happens to be on call to find the problems, the bugs in your code. That's not optimal, let's say. Otherwise, if you don't have software ownership, it starts to get grim pretty quickly. In fact, this is what I think of as like the software engineering death spiral, because it starts with, an increasingly large interval between when the code is written and deployed, which leads to bigger diffs, longer turnaround for code review, more time switching between projects, changes getting batched up, makes it harder to figure out whose changes were at fault. So now whenever a deploy breaks, it's like, okay, 5 people's afternoons are shot until we figure out what went wrong, which means that you spend more and more engineering cycles like waiting on each other and being, escalated to incorrectly, which means, more and more contention. You're going to need specialists. You're going to need people to run your deploy and release process, coordination costs. Now you need more people, which all cost more time. You can spend your life chasing all of these symptoms and pathologies, or you can fix it at the fucking source. 15 minutes or bust. This isn't just about the economic arguments. How well does your team perform? I'll remind you that we said high-performing teams get to spend most of their time doing cool shit. Lower-performing teams don't. This is a quality of life issue. Software engineering has the potential to be a creative, exciting, fulfilling career where you spend, 4, maybe 5 hours a day solving puzzles. I don't think anybody really has more than 4 or 5 hours a day of real intense engineering in them consistently, but that's fine. Like those 4 or 5 hours a day, that is what moves the business forward, right? The rest of our time at work, we spend doing email or bullshit meetings, whatever, or just don't spend it at work for all I care. Output is what matters, right? And what this means is, Dan Pink in his research said that what we care about is autonomy, mastery, and meaning, right? This is a quality of life issue, which means it's an ethical issue. So how much is your fear of continuous deployment costing you? Well, as a rule of thumb, if it takes X number of engineers to build and run your software system with a 15-minute delivery interval, if it takes you hours to deploy, it'll take you twice as many people. If it takes you days to deploy, it will take you twice as many again. And weeks, double it again. If anything, I am underestimating here because, as I said earlier, the cost of supporting the software goes up not linearly, but exponentially. And if you're like clamoring for headcount, if you're a manager who like doesn't have enough, you have too much to do and like not enough cycles, what would you do with twice as many engineering cycles? What would you build? Well, go fix your build pipeline and let's find out. Finally, this slide is on here because I was just giving this talk at a CTO conference, so I had to include this, right? Somebody, said from speaking with CTOs, they don't believe that this is safe to use resources. They think it's diminishing returns. They think that it's too risky. I hope not. If so, this is just embarrassing because the CTO has one job. Surely it's to ensure that every engineer gets to spend as much of their productive time as possible on the highest value work as possible. These minutes to hours, these small changes, they add up, they multiply. So, I know it takes time, it's an investment, but are we too busy to improve? The end.
And now I'm going to go over to questions. So please, if everyone wants to come off of mute, come back on screen. Let's see all of your lovely faces. And let's just have a little bit of a discussion and Q&A. Let's see who's got the first question.
I have a question.
Yeah, go for it.
So Charity, you spoke about keeping the feedback loops small in order to ensure that people have ownership and also that the useful information hasn't departed from their brains. Yeah. But then also about feature flags to decouple the software deployment from the feature deployment. Won't the fact that the feature might not be turned on for a month undermine the first point?
So few things. Obviously, that's not ideal. It's still better to get the code out there. Even if you are calling those functions, it's good to get it out so that it's that it's not like a landmine waiting for you. When it's feature flagged, you can open up access to like subsets of users, like for internal users or for test users or for alpha users, and that's a much better way than just like off on anyway. So hopefully you can use that to like debug the code. The key thing about feature flags I want to emphasize is that it decouples the deploys from the releases, right? That's the thing that it does for you. So you can be deploying constantly, but marketing can have their releases. It means you don't have to like sit there and like hit deploy, and it takes an hour and a half to deploy. So you're like, okay, the press release goes live at 10. So we're going to like hit deploy. I mean, raise your hand if you've ever done this, right? And then the deploy always fails. And you're like, get it out faster. So it like gets rid of those completely. And it makes it so that, these two very different functions can live separately. Now you're absolutely right. And this mostly will come into play, like if less like for user interaction stuff and more for like performance stuff. You never want to be like flipping on a flag that you think might hammer your database for the first time 100%, like a month after you've written the code. So to some extent, the cardinal law of use your engineering judgment, like there's nothing you can say or do that won't make that still true.
Nice, thanks.
Thank you very much for the talk. A quick question: how do you, actually two, if I may, how do product people react to the software of ownership that you talk about? It's almost like it's mine. No, it's mine. No, it's mine. No, it's mine. That sense of who's sort of leading the pace. And perhaps a second question, if I may, so that I don't bother you after that. What are the, I wouldn't say right metrics, but usually developers, we are very good at...
Let me answer the first one first, or else
sure. Yeah,
no worries. So when I'm talking about software ownership, I'm talking about owning the consequences of the code that you've put out into the world. I'm not talking about, design and everything. Now, I do think that's really important. Like at Honeycomb, we practice triad development, where every time we're developing something, we have a designer, a product person, and an engineer who are doing all the discovery and everything, together. But that's a completely different thing than, I'm writing this code, therefore I'm responsible for it. I'm not allowed to just deploy and walk out the door, right? Whether it's Friday or not, you don't ship and run. That's the kind of ownership I'm talking about. It's just like your job isn't done until you see it running in production. So go on, second question.
Yeah, that makes a lot of sense. Thank you. And the second one is, have I forgotten it? Yes, as developers, we tend to focus on the happy path, whether it's tests or anything. How do you improve on observability? On the happy path, the fact that things will work, basically. Sorry for my English. And I wonder, how do you optimize for the other passes, like error passes? What observability do you put in place to notice what's not working versus what should work? For example, when we write tests, we tend to look at, okay, I know that this function should return this, right? So I'm going to write a test that does this, and just completely ignore the gazillions of failures it could happen or other cases that it could actually have. Not because we are lazy or anything. It's just, I think it's a mentality of, okay, let's get that thing out.
Nobody can build like a castle in their head that will like foresee every possible outcome, right? Totally. This is a really big question, so I'll take a couple stabs at answering it, but I'm also curious like what other people here have to say about it. I would say that, part of like having this be short is that, when you're going to validate, is my code doing what I think it is, is anything, look wrong, you're much more likely to catch, oh, it's not happening, than you will if you just ship it and somebody's looking at it much later, right? There's, in order to do automatic deployment, you absolutely have to have confidence in your test coverage, which is not to say it has to be perfect, but you absolutely need to have tests and make a practice of caring about them. And then, I think of observability as being very much like tests are to staging and development as observability and instrumentation are to production. So, I kind of think of your observability tool as almost like a headlamp that you have on. So anytime you're going out to debug something, you instrument a couple steps in front of yourself instead of trying to look at the code and understand what's going on in your head. Don't rely on your head, right? Like add some counters, add some outputs, add something that will tell you the information that you want to know, and then go look at that information instead of, you know what I mean? So like that will honestly, if you start doing that, and if you have a real observability tool, by which I mean you have to be able to slice and dice down to the raw requests, which are arbitrary. This matters because you have to be able to tell precisely, if you've deployed this build ID, then how are these requests for that build ID differing from those requests with the other build ID, and maybe they're different in these 4 ways, right? And that's really valuable for you to know. And I would hesitate to do some of this stuff without having real observability, because otherwise there is just so much that goes on that's broken in your systems all the time that you have no idea about. Sorry, is that helpful? Does anyone else have something to add to that?
Yeah, I think what Charity said makes sense, right? But it's also about making sure that you're observing the error path. And to your slicing and dicing thing, it's looking at how things change over time. So one of the things that we do, it's not 15 minutes, it's actually closer to 20 minutes, but we're getting there. We actually track error rates over those 20 minutes and then actually have automated rollback if they go over a specific threshold.
Nice. There's a lot of stuff that you can do too that kind of once you kind of shifted your perspective from make it work to okay, a lot of times it isn't going to work, but let's make it graceful and not impact our users. Then you can do canary deploys. You can deploy to one node and then compare them for a while, or roll them out to 10% and then bake for a while. It just depends on what your threshold, what your appetite for risk is, what your threshold for error is, and how much time you can afford to pour into it.
How have you, over the years, helped engineers who feel like, yeah, that's awesome, I want to get there, my team would like to get there, but feeling overwhelmed by the journey ahead, basically? Totally. Because obviously I look at your talk and shit, obviously I want that. How do I get there? How do I start?
Engineers who have worked this way are not willing to go back to working any other way, in my experience, because you just get used to and it feels like just being tied down, artificially constrained, and it's a shame. Like, this is not rocket science. This is not hard. But it is work. I'm not saying that I'm not saying that it's easy, but it's just engineering, right? Getting the amount of time it takes you to run the test down to something tractable and deploying your code. It's just engineering. It just needs to be done. There's nothing super fancy about it. You just need something. That's a really good place to start is by instrumenting your build pipeline as a trace. So you could actually see where all that time is going. You can do that with Honeycomb using the free tier. You don't have to pay any money, and you can just see where's the time going. And if you make it part of your on-call rotation to just pay down some of that debt, it'll shrink really quickly. And the thing is that I know it's hard to get time away from shipping features to work on this stuff, but the gains, the productivity for your engineers, it pays off. It pays off so quickly, and once people start to feel that, it starts to feed on itself, and people get excited looking for other ways to. In my experience, the biggest obstacle that most teams have is that they don't think they deserve nice things. They're like, well, yeah, this is for Google and Facebook, and this is for blah, 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 blah. And, no, that's bullshit. It is easier to work this way than it is to work the way that you're working right now. I guarantee you. It's simpler. It's faster. You have to store less in your head. And if you can write tests, if you have 75, 80% confidence in your tests, you are tall enough to ride this ride 100,000%. In my experience, most teams just, they don't have the confidence in themselves. It does take someone to be an advocate, to stand up and be willing to lead the charge. And so most of the times I see that this happens when somebody comes in from the outside, somebody gets hired who has been in a team that has done this before. So they come in and they're like, no, guys, you're totally we can do this, and then they do it, and then they gain the confidence. But it's all about just confidence and believing that you deserve it, and having a functional enough, relationship with your product and non-engineering teams to be able to make a muscular case for why this is not wasted time. This is not navel gazing. This is an investment. This is not taking on, debt to buy a nice car. This is taking on debt to put yourself through college, and everybody's going to be better off. That was a long answer. Sorry.
That was a long question as well, so it's fine.
If I can just add to that, in my experience, especially if you're in a position where you have a team who sort of knows what they want to do, but they're held back by the business, or it's not a priority, whatever, getting the business to spend money on it in any form will help, because it will suddenly put a price on not doing it. Even if it's a consultant who comes in for 2 weeks and tells you stuff you already know.
Totally.
Because if you don't do what the consultant then says, you've then wasted money. That can be exceptionally helpful, even if you learn absolutely nothing. Forcing the business to put a price of some kind on it can be a good way to, if you're looking for management buy-in, to sort of get people off their asses and be like, well, we spent all this money on it. We have to use what this person said, even if you told them what to say, because you already knew what you wanted to do.
That's amazing. I never thought of that. I'm so excited. I can't wait.
I'm just going to plus one to Dylan. That is the most excellent tactic ever. The second best tactic is using internal audit. Audit found a risk. Now we have to do this work.
What's an internal audit? Is that a security thing?
It can be a security audit. It can be a business audit. Some of the bigger companies, medium and large size companies, will actually have an internal audit group, looking to check to make sure that you complying with regulatory things PCI or SOX or things like that. So they'll come along and they'll check to make sure that you've got good deployment policies. And if you get a bad tick on your deployment policies, then guess what? You've got to spend money on it. So
That's amazing. I'm writing these things down. If you guys are on Twitter and you want to tweet it, I will retweet the hell out of it. I've been meaning to write an article about this, like the distance between where people are and this talking of the glorious future. Like, what are ways to like cross that gap? So I'm absolutely going to write about these, and I will use your names. Thank you so much. Anybody else?
I'm just laughing. I'm like, I wonder who will see that and go, damn it, that's what she did to us.
Sorry. Is it okay if I use your name?
Yeah, no, I think it's good. I just needed to process that.
Has anybody else here tried some sort of this before? Like, what has worked for you? What hasn't worked for you?
Yeah, I did it as a consultant, and I said that one of the things that the CTO should do is start to do an on-call rota, and then pay for call-out fees, and then you work out how shit the code actually really is, because now they actually have to look after it for the first time ever, and then they start to really care about it, because they're the ones getting called out every night, all night. And then there starts to be like some inter-team competitions that were happening, because one team got called out in their week rota like 3 times and the other got 7. So they're actually like twice as worse as this team. And then there's now healthy competition between teams to actually improve what they're doing.
Yeah. Now our egos get involved, and then things really take off.
Exactly.
It's brilliant. Yeah, you're totally right. Like, it's all about finding ways to convert engineering speak into dollar speak, right? Because a lot of times when we talk about things that we want to do in engineering, it sounds like, from the Snoopy cartoon where the adults are just like, wah, 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 wah. Like, how are they supposed to evaluate that, right? It's really on us to translate our needs into language. And I think that as engineers, we get hung up on because it's not accurate. It's like, it's not accurate. I don't know how to estimate the stuff. It's any estimate is going to be like, hundreds of thousands of dollars. It's not accurate. But like, the thing is that, like, it doesn't have to be. It just has to be a number that you can defend in a sentence, right? Because business folks don't get hung up on numbers being accurate. They're like, well, $20,000 a week or something. And if you can like back it up and talk about it just in a sentence or two, that's good enough to go on, right? Like, nobody's like, well, you're $5,000 off, but they have to have some sense of what it's costing you to live this way. Yeah, Amy.
Yeah, I was just going to say, one of the things that I've got one of my teams working on right now, which is it's going rockily, but they're working on it, is trying to create a way to score the impact of an incident. So like you can say, oh, it's missed minutes, or it's, a knock to your availability. You can come up with all of these like really, very data centric, very software development, focused types of metrics, about your service. But if you can then translate that into a number that describes the impact that your customers felt from that. We're working on that now. Again, it's not going very well, but we're working on it. But this is like the holy grail for me, to be able to walk into, a monthly director meeting and say, hey, the incident that you all are focused on was a 43, but the one that I'm focused on was the 67, and you should be looking at the 67 because, our algorithm says, it's weighted in this way. And that's what customers, that was the thing that really hurt people. But yeah, it's an idea. We'll get there eventually with something, but yeah.
If you do, please write an article about it, just like describing your methodology and like what went into it. Because I think this is something that a lot of teams deal with, and it could be a really interesting conversation to have. Just like, yeah. I don't know. Where do you work? Do you work at a place that's really private about this stuff, or?
A little bit. I work at Microsoft.
Okay. Well, yeah. All right. Well, anyway, That is
I can talk about it. Obviously I work for OneDrive and SharePoint. So, big services with lots of people using them. And we care a lot about customer pain because they're enterprises, customers. So yeah, we just got to find a better way to talk about it so that, and so that it's consistent across a large engineering org, right?
You just have to learn how to translate it, right?
Yeah, exactly. It's translation.
Translation. Yeah. Anybody else who hasn't talked yet? Anybody have?
Oh, sorry, Dylan. I didn't see your eye. Go ahead.
Anybody who hasn't talked yet? Then go for it, Sylvan.
Dylan, go first.
Thank you. What I was going to ask was, have you seen anybody doing a similar thing on a pure infrastructure front, like developing infrastructure as code and releasing it every 15 minutes and going through the whole feature?
Oh, yeah. So that's a great question. 1 second. Yeah, so we basically do that. But here's where I think it's not worth it for most folks. Like, obviously you should do the infrastructure as code thing, but like getting it down to 15 minutes or less and keeping it, short and everything, I think is mostly a waste of time because, there are kind of two different types of software, if you will. There's the code that you write that's like your crown jewels. It's why you exist as a company. This is your business, right? And then there's all the code that you have to run in order to run that code, right? And so the stuff that, is your business, you should know like how it works, every inch of it. You should be able to turn it around really, really quickly, right? Because that's your business. But then there's other stuff like Linux, right? Terraform, where unless it's core to your business, you're fine with it changing at the speed of package updates and, installs and everything, because your business it probably doesn't matter whether it takes an hour or 15 minutes to roll out, or 4 hours, right? As long as it's predictable and it works. So, I always recommend that people kind of try to distinguish those two as much as possible, because if you're in a state where you have to, roll out the stuff that's slow really fast or vice versa, it just gets really, it's less clear and there are problems. You can probably imagine what they look like.
Cool. Thanks. Thank you, Sylvian. Sorry.
Yeah, no, happy to. I'm part of a team, and as part of that team, I've noticed that one thing I'd never noticed before was the balance between the characters of the team, having people with more at ease to speak out, right? People less at ease to speak out, and therefore that sort of balance. How do you feel having a sort of a data-driven? Because at the end of the day, I see what you've discussed about a little bit like that. At least there is one side of it, being data or evidence-driven. Numbers don't lie in a way. Have you noticed that it has helped some, I wouldn't say dysfunctional team, but certainly teams to be less about one character in the team owning the team in a way and helping people who usually aren't very perhaps shy or things like that. So do you feel like having a data-driven and therefore being able to say, well, it's not about you, it's about a team, what we the outcome of the team. Have you noticed it helped? It has helped.
I think I understand what you're saying, and yes, there's a few things interwoven there. I think that first of all, like on call, I think is a great leveler, and I think this is why it's so important for engineers to be on call and own their code. I think that setting like an internal, like an SLO, right? Like we want our deploys, our tests to run to take 15 minutes, right? So if it gets larger than that, whoever's on call will go and having like SLOs are great because they're like, it's like an API, right? It's like, you're right. There's no personalities involved, just we've committed to this, right? And we'll take turns like supporting it. So it's much less likely to be like, all right, there's the build guy who does all the stuff related to build and release. It's like, no, this is a shared resource that we jointly, maintain. And we're all we agree to like have it at this level of service. When it comes to, there's something interwoven here with observability, which I've noticed, which is that, with traditional tools, there's a pattern where the best debugger always seems to be the person who's been there the longest, right? Because they built the thing, they've been there forever, they've seen all the outages, so like something happens, they can like look at the dashboards and just like intuit, there's the answer, right? I love being that person. I love just being like, it's Redis. Like, I know, it doesn't say it anywhere, but like, I just know. But that's really demoralizing, right? For everyone else. And it's not a healthy thing because, that person who's been there forever, wants to go on vacation too. And I have seen a shift, like from that scenario to a scenario where the best debuggers are the people who are the most curious and the people who consistently look at their code in production. That shift is like less about build and release and more about observability. Having a tool that will let you like get instead of like all the state having to live in your head, instead like getting out of your head and putting it in a tool where you can slice and dice and like find the answer consistently. And it doesn't take a lot of prior knowledge about what to look for, what to match. And that's one of the most exciting things about observability to me is that it has this kind of democratizing potential to unlock, what your code is actually doing and make that accessible to you. Something that we have in Honeycomb that I also love, I know it's a bit of a digression, but you know how you're debugging, you'll be like asking questions, well, maybe it's that, no, not that. And you have to back that a little bit and find the place where you last knew that you had it. Well, we store all of your history on the right. So every graph, every query that you've ever done, so you can like scroll down and go, oh, that's where I had it. Click, go back to there and keep iterating. And we also store your team's history. So like all the queries that anyone in your team has made for this data set are stored in a tab right next to it. So, sometimes when I don't know where to start, because it's not my service, right? I just look at like, what does an expert look at when they look at this service, right? Or like if I get paged late at night, maybe it's something about MySQL and I'm not a MySQL expert, but I know the experts on our team are like Ben and Emily. So I'm going to look at like, what did Ben or Emily look at when they last looked at this, right? Or if I'm like, hey, there's an outage like this, I think last Thanksgiving, I'm going to go look at like last Thanksgiving, like what were they doing? And I just think that that's so, I want everyone to have this, right? Because so much of your knowledge is in your brain, and collaboration is just as much about you collaborating with your past self and your future self as it is collaborating with your teams, right? Because I forget everything that I've debugged like within a few months. I'm like, oh, I did that. Well, good on me. I don't remember it. So yeah, that's something I feel really strongly about, but I recognize that it's very Honeycomb specific. I do think better tools are such an equalizer. Better tools, like in the last 5 years, we've really seen like a sort of shift towards production-centered tooling, right? Assuming that, you're going to get your stuff into prod as quickly as possible. And then, having progressive deployments and having, chaos engineering and having, feature flags and having observability and all these things like, when I was saying at the beginning about how, steady state, you're losing ground as an engineering team, like these are step functions, right? These give your team an entire leap up. They make you waste a lot less time and they make you get your job done much more quickly. And, to people who are struggling to justify the cost to their, financial teams, I think it's right back to, what Amy and Dylan and Steve were saying about, just translate it into dollars. It's so easy for most engineering leaders to get headcount and so hard for them to pay a couple $100,000 for a tool. But the amount of surface area that your team has to own, you should keep that as small as possible, right? And just focus your team's engineering cycles on them like a laser.
Thank you so much.
Yeah. I'm let's 4 more minutes and then I got to hop off. Do we rely on staging heavily a bit less than in the past? So our staging is actually a fully functional, our production environment, it runs like the combined workloads of like 350 customers. So it's like tens of millions of requests per second. And that's all instrumented and goes into our staging cluster, dog food cluster. So it's a very active, like it's production-y too, right? And because we want to know when, stuff is wrong with that, that feeds into Kibble. So Yes and no. Like, I think that there are roles. There's a real role to be played by non-production environments, but they don't look like the staging of days of yore, right? Where it's like you manually deploy to it and it's just kind of sitting there rotting most of the time. It drifts away from production, and you use it just for like a lot of manual testing. Like, I think that, you want to get your code into an environment where real things are happening, because you need the chaos that's introduced by users, not just like automated tests. And yeah, this is a really broad question. And I think that, what's your use case?
No, I was just curious with such a high speed of deploying to production. I was wondering if it basically removed the need for like a staging or whatever arena first.
Yeah, I mean, we don't really have a staging cluster in the sense that most people use staging. Yeah, in fact, I used to give a talk about killing staging clusters, and it was super fun. But then everybody got really nervous and upset, so I stopped giving it because I got tired of explaining myself.
Yeah, I'm the same as Charity as well. We don't have a staging environment. We have a kind of sandbox or demo environment, or a demo platform. Then we have a production platform, and then we have what you would call dog food, I guess. We kind of call production one. Terrible name, but essentially does the same kind of thing. Plays the same requests through that system, but actually the one thing it does do is it turns all the feature toggles on, so that we get all the flows through the system that could ever be possibly turned on. Whereas production, there may be some turned on or off. And to your point, I can't remember who made the point of what about if I turn the feature toggle on 1 month later? That kind of mitigates that a little bit, because we're running requests through the system that have all the feature toggles turned on.
Nice.
Right.
That's brilliant.
Well, thanks, everyone. I think that's all we have time for this evening. Charity, thank you so much for delivering the talk, and for everyone that's participated in our
question. And the answer is I really enjoyed chatting with all of you.
Lovely. And Charity, you mentioned your book. We'd love to get that posted out onto the Meetup page. If you can ping me the link again, that would be wonderful, and we'll share that out. And also, if everyone can stay tuned for our next meet, we'll be joining on the 9th of June. We'll be back, but this time for a lunchtime session. So it'll be our first demo day. So please do watch this space. Details will be announced shortly. But thanks, everyone, for joining, and hope everyone has a lovely rest of their day, evenings, mornings. Thanks all.